Well, hello there and welcome back to another video. So today we are continuing where we left Advent of Code last time. I don't have that much time, but let's try to squeeze something out of, I don't know, an hour or an hour and a half at most. So where were we? Day 20. So day 20, Grove Positioning System. I always have trouble with the word grove because I instinctively try to read it as groove. So Grove Positioning System. It's finally time to meet back with the elves. When you try to contact them, however, you get no reply. Perhaps you are out of range? You know, they are headed to the grove where the star fruit grows. So if you can figure out where it is, you should be able to meet back with them. Fortunately, your handheld device has a file, your input file, that contains the grove's coordinates. Unfortunately, the file is encrypted. Okay. Just in case the device were to fall into the wrong hands. Yeah, like how important is this grove with star fruits? Maybe you can decrypt it? When you were still back in the camp, you overheard some elves talking about coordinate file encryption. The main operation involved in decrypting the file is called mixing. The encrypted file is a list of numbers. To mix the file, move each number forward or backward in the file a number of positions equal to the value of the number being moved. Okay, the list is circular, so moving a number off one end of the list wraps back around to the other end as if the ends were connected. Okay. For example, to move 1 in a sequence like 4, 5, 6, 1, 7, 8, 9, the 1 moves 1 position forwards. Okay, so it moves, yeah, it was here, it moved there. To move the -2 in a sequence like 4, -2, 5, 6, 7, 8, 9, the -2 moves 2 positions backward, wrapping around. Okay, so I guess it ends that up here. So first it goes here and it's between the 4 and the 9, I guess, or in position, now it is in position 1, then it goes into position 0. And 1 less than that, well, I'm not so sure of why it goes to, like it wraps around, but it goes, 1 more than what I would expect, I think. Like, I don't know if a minus, like could have it, well, this is circular, so I guess it doesn't make a difference. I wonder if I will need to make a circular list. The numbers should be moved in the order they originally appear in the encrypted file. Numbers move, okay, in the order they originally appear in the encrypted file, so we have to keep a copy of the original ordering. Numbers moving around during the mixing process do not change the order in which the numbers are moved. Okay, consider the encrypted file 1, 2, -3, 3, -2, 0, 4. Mixing this file proceeds as follows. This is the initial arrangement. 1 moves between 2 and -3, so we have, yeah, makes sense. 2 moves between -3 and 3, so 2 was here, it gets moved here, that makes sense. -3 moves between -2 and 0, so -3 is here. It moves 3 to the left, so 1, 2, 3, yes, it ends up here. Okay, I see. Does this make all the sense in the world? I guess it does. Okay, so we move everything. Then the grove coordinates can be found by looking at the 1000, 2000 and 3000 numbers after the value 0, wrapping around the list as necessary. In the example above, the 10,000th number after 0 is 4. The 2000 is many 3, and the 3000 is 2. Adding these together produces 3. Okay. Mix your encrypted file exactly once. What is the sum of the 3 numbers that form the growth coordinates? Okay. And here's the input. Let's take a look at that. All right. Yeah, there are many numbers. I cannot see the scroll bar. Here it is. Okay, so it seems like it's a pretty long file, and some of these numbers are actually quite large, like 8,000. Okay, that makes me wonder. Let's go to Advent of Code, blah, fire the editor. Let's do a new file here. So this is day20 txt, and let's copy the actual input. So I want to check some things about this. Okay, so it is 5,000 lines. Interesting that many of the numbers are larger than this. So some of the numbers will wrap around like more than one loop around the file when mixing them. Interesting. This is like a circular list. I wonder if I should implement something like this, or maybe if I can get away with using vectors, plain vectors. Also, when you start to mix up the numbers, you don't have them in the original order that they came, so you will need to find them in the file. And I guess also I would like to know if these things are unique. So let's do what? Well, let's cat this input day 20. Let's sort it, and let's unique, and let's word count. Oh, they are not unique. Interesting. Was it unique minus C to count? Yeah. Okay, so some of the things are repeated, like 9988 is twice in here. Interesting. Oh, so that's an extra problem, right? I have to remember which numbers they are, because there are two 9988. Sorry for the background noise there. I should also maybe close Steam. Did it close? Come on. Okay, bye. So I have to remember like which 9988 it is once I start mixing around these things. Interesting, interesting, very interesting. So should I give this number sort of an ID? That doesn't seem very logical. And yeah, okay, it's like in my mind it probably makes sense to use a sort of circular list, but I think I'm going to try and get away with a vector if I can, and see how it goes. So this is day 20. What was the name? Day 20 grove positioning system. Grove positioning system. All right. Let's no, not rename, just a new file here. So you can hear the Colchonero in the background. I'll pause the recording for a bit. How was pausing? Was this shortcut? No, not that. Control Shift Y? No, not really. Well, let's pause in here. No, not stop recording. Okay, and I'm back. So yeah, I just closed the door to maybe reduce the background noise a little bit. And I just checked the pause and resume shortcut, which is meta W. Nice to know. Okay, so let's try to figure this thing out. Also, I don't want to, maybe I want to try out the most naive approach of using a vector first, and then see what's part 2 is about, and only then decide, like, well, what makes more sense. Row positioning system, yes. Okay. So first, let's parse these numbers. I think what I'll want is to have, let's see, call mixing. Encrypted file, okay. Oh man, this Sherpa is not very good. All right. I will also copy the sample input just to work with something more manageable at the beginning. Okay, so let's say we're gonna have a mutable thing. No, not mute. Let's call it numbers. Although they are not going to be just numbers, they're going to be a pair of the original position in the file and the number itself. So well, let's call it, yeah, just numbers for now. Back. And let's just use a tuple of the original position and the part number, which is signed. So let's use a 32 signed number. Why not 64? As I'm using a 64 bit computer. So let's do input lines. We're gonna enumerate these things, and we are gonna map into what? Well, we're gonna have the index and then a string. Well, and what are we going to map to? Finally, we're going to collect this, but we are going to map just into that index, and this thing parsed. And we are going to expect a valid number. Yeah, why not? Okay, so we have this thing. Let's just sanity check this. Yeah, it doesn't need to be mutable, but no problem. Let's run this. Okay, and it complains about the to-do, but this thing looks alright. Alright, then what are we going to do? We're gonna be mixing these things together. So we're gonna go for I in not in numbers. We're gonna do this numbers length. And we're gonna do a mixing operation for each of these. First, we need to find the number on this list. That's why we are storing these things. And then how are we going to move this around using a vector? So I'm thinking like an intelligent way of doing this, or intelligent, not really intelligent. But if you have the current the current position and the position that you want to go, you could swap everything in between and then put the number in its place. But if we do that, I don't really know about the behavior of like wrapping around. And we have already seen that some of these numbers are big in the actual input file, and they like wrap around more than once. We don't have an example of this in the sample because these are 7 numbers and none of them is bigger than 7. But in the real input we do. They are 5,000 and some of them are larger than that. So I think I'm going to do a very naive solution of just iterating, I don't know, suppose that the number is 8,000, iterating 8,000 times and swapping indices in the vector, which is really pretty. Yeah, but I think that's the like most naive but simple approach, I think. Okay, so we need to find this on the numbers. So can I find, or we have index of what? Performs the indexing operation. No, I don't want that. I want, maybe I need to do an iter find. I would prefer not to. But also this will give me an option of the thing. Now what I want is give me the index of this position, I think it is. Yeah, position. Does vector has a position? No, not really. So can I iterate? Okay. We're gonna find the position of these things where this thing, I guess original position, and the number we are gonna ignore, where the original position is I, and we know that I guess this position will return an option, right? Yeah, but we know that this option is like there should be a number with this, so expect number must be on the list. Okay, I guess this is reference, so the reference. And now we have the position, which is, say, let's current, well, just index, let's say. So this index is different than like the original index. Let's call it original index. Actually, I kind of like position as a name, so let's call it position. So this is the current position, this is the original position, fine. And we are gonna basically be moving this guy yeah, we're gonna move this position around, I think. So how do we do that? We could say, let's divide the cases of moving forwards and moving backwards. So they can probably be unified, but let's think about it one at a time. So if position is greater or equal than 0, is a move forward? No, position is not what I want. I want the number. So let's number be numbers actually yeah, I think what I want is probably like I already have this. I should already, but anyway, let's do numbers in this position. The second, like the second thing on this tab. Okay. So if the number is greater than 0, then we are moving forwards. So how are we going to do this? I think a simple way to do this could be incrementing this position num times and swapping this with the next, and always using modular arithmetic, so things wrap around nicely. Right? Does that make sense? Can I do like for whatever in 0 up to this number? So this amount of times do next position will be position plus 1, but we are gonna use modular arithmetic. Let's extract numbers dot len. I don't know if this makes the most sense, because when we move it to, like, the last position is the same, I think, as the first position, as we have seen in the examples. Like if we wrap around, let's see, 3 is here, it moves up to here, 4 is here, and it moves here. So it basically moves 1, it's not 1, 2, 3, 4. Like when it moves here is the same as it is as it would be on the first position, right? Yeah. So how do we do this? The first time it moves, we can do a swap between 4 and -2. That is fine. But then we shouldn't be swapping 4 and 1. Although we kind of do. If we do that, 4 and 1, 1 would be here and 4 would be here, then swap these two and then swap these two. I think that would work also. Yeah, it's just it will get the list would be in a different order than like it will start from a different point, but if we think it circularly, it would still be the same, I think. And since we count the final solution is starting from 0 and counting around, I think it won't matter. Let's try. So we have the next position, okay, and for each of them we're gonna do numbers, swap, position, and next position, and then position is gonna be next position, and this means that position should be mutable. All right, that sort of makes sense. Else, panic. Let's try this out. Or to do, move backward. And after doing this, let's print the current numbers. I guess I want to print the numbers, just the second of them. Iter, oh come on, map. Collect into a vector of stuff. Okay, that was a mouthful. But let's see what it does. Yeah, move backwards. Okay, not yet implemented. Nice error message. But let's see what happens. So, oh, I should also maybe print the original. But well, this is after the first mixing. One moves between 2 and 3. So 1 ends up here. Is this what we see? Yes, 1. So it's 2, 1, minus 3. Okay, that was good enough. Then 2 moves between minus 3 and 3. 2 was here, and it moves here. Do we see that? Yes, we do. And then we have to move backwards. Okay, how do we do the moving backwards? I think we're gonna do something very similar. Just, yeah, we're gonna just do for this. It's a negative number, so we can do this. Actually, it's basically the same thing, so I guess we can unify these two guys, but position, what the hell is this? It's a U size, so I don't want this to be, to do an underflow. I want to do modular arithmetic. Yes, so do we have like a div? What the hell is div? Euclid wrapping div. What is this? No, I don't want to wrapping div, but what is div Euclid? Oh, there. Reminder? But does it have a mod? What is the rem Euclid? Calculates the least remainder of self mod right hand side. Oh, beautiful. So what do I want? Rust? I don't want to be converting into signed and into unsigned. Oh no, but I do need to do -1. So okay, let's. I wonder. So pause. I guess I can say as eye size. Yes, sort of this, but then because once we do the mod, we get a positive number, so then we can say as use size. Yeah, quite horrible, but let's roll with it and let's see what happens now. What's index out of bounds? The length is 7. Is it 7? Yes, it is. But index is this giant number, so we wrapped around. Hey, my cat wants to be on top of me. Come on, Simona. All right, I have my cats on my lap now. So we overflowed or underflowed. Very good. Let's see. This is coming from, yes, this swap. So I guess the next position we're subtracting 1. Doesn't the modulus do what I think it does? Let's do some print debugging. Println. Well, we have pause. Pause -1. This is pretty stupid, but okay. And mod. Okay, so let's have this thing, and also this thing. Like, where does it go wrong? What's your problem? Argument never used. Sure. Starts with position 1. So what we are moving around now is the -3, which is at position 1. That is fine. Position -1 is 0. The mod gives us 0. That is good. Oh, look at this. Position -1 is and then modular. So mod is not mod. I thought that this thing would always give a positive number, but it seems it doesn't. So yeah, let's last mod operator. Yeah, I don't want this. Oh, okay, so it was rem Euclid what I want. So if we do, instead of this, we do rem Euclid of this thing. We run now. Yeah, and we get the wraparound behavior that we wanted. Okay. Interesting. Very interesting. And I guess I still need the as uses, right? Yes, because otherwise next position is an signed integer. But let's see now. Okay, we have this final vector, which I think is not going to be the same as this, but it should just be shifted. So let's see, starting from 1, 2 is 1, 2, minus 3, 4, 0, 3, minus 2. 1, 2, minus 3, 4. Yes, 0, 3, yes, and minus 2. That's great. Awesome. So, this is quite ugly. Let's make it more consistent. Move backward. Okay, so we have done all the mixing. Let's now compute the position. So yeah, we need this. How are we going to do that? I guess we can say 1000, 2000, and 3000. We have to sum these things, so we're gonna iterate. Map index and how do we want to do this? I guess we could find the index of 0, right? So we can say let 0 position. It's gonna be this kind of thing. Beautiful. Now what I need to do though is I don't care about the original position now, so this is fine. I only care about the number, and I want to know if the number is 0, and I have to say 0 or 0 must be on this list. And you don't like this because I screwed this up. Okay, and then we are gonna do numbers having the 0 position plus this index, all of this wrapping around. So wrap around the length. And of these things, I want to, were we adding these numbers, right? Yes. So we want the second of this and then a sum. And this is that from the growth coordinates. Beautiful. So this is let's growth coordinates is this thing. And I guess the sum is gonna be whatever type we were using here, i64. Beautiful. And just format is not growth coordinates. Okay, let's run. And the answer is 3. Yes, very cool. Let's try to do it with actual input and run again. And it took like 1 second, but it didn't explode, so that's a good sign. Let's try this solution. Yes, okay. We got away with a simple vector and no circular linked list or shenanigans like that. So this is pretty simple, and it's of course we can of course improve this. But let's see what part 2 is about, because I have the feeling that it's probably going to get much more complicated. Okay, the growth coordinate value seems nonsensical. Bummer. While you ponder the mysteries of ELF encryption, you suddenly remember the rest of the decryption routine you overheard back at camp. First, you need to apply the decryption key, this thing, multiply each number by the decryption key before you begin. This will produce the actual list of numbers to mix. Okay. Second, you need to mix the list of numbers 10 times. The order in which the numbers are mixed does not change during mixing. The numbers are still moved in the order they appear in the original pre-mixed list. So if -3 appears fourth in the original list of numbers to mix, -3 will be the fourth number to move during each round of mixing. Using the same example as above, this is the initial arrangement, so we start by multiplying the numbers with this decryption key, and we do all the wrapping around because now these numbers are huge. Okay. Very nice. We're gonna have to implement some clever solution for this. The growth coordinates can still be found in the same way. Here the 1000 number is this, the 4000 is this, and the 3000 is this. Apply the decryption key and mix your encrypted file 10 times. What is the sum of the 3 numbers that form the growth coordinates? Okay. Very nice. This complicates things quite a bit because we have numbers as big as 800 million. And we have already seen that in the actual input, we have numbers that are like 9,000. So let's say 10,000 to round it up. That is like a very big number, actually. I cannot even think about it. It's like almost 1 trillion. So 1 trillion operations is not feasible. It's not feasible even using a circular list and reading the next every time. So that's not a good idea. So what are we going to do? So one way of implementing like a linked list without actually making a linked list, because well, I guess the Rust standard library has one of those to use. I think I've never used it, but implemented it by hand is famously something pretty hard to do in Rust, because you like dealing with the ownership issues of the memory is not very pleasant. So an alternative of doing that is using some sort of hash map that could be like, let's say, a hash map of like original number to a pair of numbers that says like which one is the previous and which one is the next. And if you do that, well, still, you would have to advance many times around. Trying to think, how is this gonna be made? Like this, I wonder if this is like a super clever problem where you need something like dynamic programming or something like that, which I'm always terrible at, like figuring out how those things work. But in this case, like the problem will be with these internal loops. Like this naive solution is not going to scale up to what we have, right? We can try it out, maybe. Yeah, I guess we can try it out. We have the numbers. And we have the mixing operation. So, and once we apply this decryption thing, I think we forget about the initial numbers. So, okay, let's do something different, I guess. Let's add these changes. So we know we have a working part 1 solution. I want to first extract out the this thing into a routine, or a function, I should say. Sure. Let's say function simply mix. It's going to be this, and this is just going to be the return value, which I guess is going to be I64, and we do need 64-bit numbers for these bigger things, I think. Well, this thing is going to receive the numbers to mix, and let's just receive a slice of I64. Okay, and we are going to print. So here I think we're gonna have something like this. don't need to enumerate. Gonna have something like that. We're gonna mix these numbers, right? But actually, let's call this original numbers. And let's say let's mutable numbers. Let's go back to what we had just extracted. Oh, and also we have to mix 10 times, so that's gonna be that's gonna be a lot. Yeah. Okay. This should be original numbers. Let's iterate over this. Let's say what's enumerate and map, and we're gonna have. Actually, I think that's what I want. Collect numbers is now sort of what I want, but here it's a double reference. Yeah, now let's do a cloned iterate. Like probably into iterator doesn't work here because I cannot consume these things. Oh, I can. Huh. Okay. Oh no, but this is still a reference. And what is if I don't use this? Still a reference. Okay. So I guess we can use a cloned iterator. And now I have what I want. Okay. And if I run this now, 8721, still get the same solution. Okay. That is fine. But we want to do this mixing a given amount of times. So let's say that this also receives like a mix count. How does it? Need to mix the list of numbers 10 times. Okay. Gonna have something like this. Something like this. And we're gonna do for whatever in 0 to mix count, do this thing. Beautiful. The solution should still be the same. It's taking 1 second. What happens if we run it in release mode? It should be pretty much faster in release. Oh, it's not so much faster. Bounce checking is probably, yeah, it's probably incurring some cost here. Okay, so I think it's just going to take way too long. Decryption key. Let's say decrypted numbers is going to be this. Let's decrypted numbers. It's going to be numbers. And let's map to n times this thing and collect these guys. Yeah, and you need to be a vector of some things. I guess I can tell you what I'm expecting. So we're gonna have the two answers, but this won't finish running. So mix the decrypted numbers 10 times, right? So let's go to the sample solution. And what can we do? Maybe say let's say here well, I guess if the mix count is greater than 1, we're gonna print this, so we don't print this on the part 1. Then mixing this number, so maybe have an idea of how long it's gonna take. Well, it's not then mixing the first number. Well, there it goes. It mixed the first out of 7, and the second one is taking much longer. Yay, look at it go. And actually, oh well, the first one was 1, so that's fine. Yeah, no, it's impossible. Like it's going to take way too long, even for this sample file. So this is terrible. Very nice. So we actually have to think of what we want to do here. Okay. So how can we do this mixing in... Basically, I want to find a solution to be able to do this in constant time or some less than linear time. Like maybe if I have some sort of heap or something and we can do it in logarithmic time, that could still work, I guess. Yeah. Okay, so let's think. If we have something like another thing is we cannot even have is this number somehow special? It is a big number, but let's ask something about this. Factors of this. No, factor. Oh, it's a prime number. Interesting. It's a prime number. What does that tell us? That should tell us something, right? If it is a prime number, like one thing that I'm thinking of is we can compute the end position of this directly, of course, like by doing, I think I say of course, but I'm not that sure, because of the moving properties of this thing. But we can try it out, like doing something like, well, we have this pause here. We can say that let's new position be something like pause plus number, and remember that this position is U size, so let's convert it, and well, the number is I64, let's say as I64, and I'm mixing here I64 and I size. Okay. But we can have something like this, wrapped by length, right? Something like this. But then it's not just a matter of switching, like putting this number into this new position. We'll have to then move everything else, but I don't want to do that, like moving of everything else. If we had like the previous and next of each number, then I guess we don't need to move everything around, right? We can just change the previous and next of the initial neighbors of this number, like when it was in this position, and then wait, when we have the new position, we have to know which number is in that new position, and that is, I think, not trivial. I think that's not trivial either. Once we know the new position, what can we say? Let's make one test and see. Like we know that this thing is working for the first, so let's just put 0 here. Like it's working for part 1, right? We do have this. Let's also print what we were printing before. I shouldn't have commented it out or removed it. So let's do a println of the numbers. Come on. Collect into a vector of stuff. Yeah, this thing needs to be debug printed. Fine. No, not factor. Run this. So here we have some things that go around the end or the beginning of the vector, but we don't have things that wrap around a lot. So let's have that. Let's say that we also have a number. Well, let's put it like in the middle. this thing will be 8 numbers in total. Let's say, I don't know, 11. So this is 3 more than 8. Let's just say 10 to have a round number. Whatever. So the 10, well, let's actually add mixed the number num. When we mixed 10, what do we have? Yes, we have this 10. It moved from this position to here, which is like 2 more. So it made 8 turns and then this and this. But it's not like it fell into here. It didn't fall into between 3 and 0. It fell between 0 and 4. Because it's like the first time it went around, it moved these things. Like, I don't know if this is, well, this is correct actually, because we know that for the actual input, this is what gives the correct solution. So it's not very trivial, I think, to know how to do this. Yeah, I'm a bit lost in how are we going to do this efficiently. Yeah, this is the classic advent of code where part 1 is relatively easy, but then part 2 is like, yeah, no, you actually have to think now. Yeah, this is interesting. We actually get an answer of 0, which is also interesting. If we do have the neighbors for each of these numbers, and we have something like what else do we want? Like we can compute the end position of the number directly, but all this shuffling, well, actually this is the position in the vector, but it's not the position like in between which 2 numbers is going to be. So, because let's try to follow it up. This is a 10. It's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 between 3 and 0. But it's not what we get actually. Why not? Did I count correctly? So it's here. I have to think about between commas. 1, 2, 3, 4, 5, 6, 7, 8, 9, no, and 10. Okay. So it's between 0 and 4. As we see here. So why is that? Because you basically do next 10 times. It's not just doing like a +1. Because everything gets shifted. yeah, we can see that everything, all of this got shifted by 1, and the 3 got shifted by 2, as well as the 3 and the like -3, 3 and 0 got shifted by 2. And if 10, let's try that. If we have, instead of 10, let's try with 18, the end position of that number is going to be the same in the vector, but everything will be shifted one more, I think. So here we have 18. Yes, and instead of ending between 0 and 4, it ended between 4 and -2. Okay, so I guess we could say something like +1. No, but I mean, it would be so bad to have like a vector of which number is in each position, I think, because we are gonna have to be doing lots of shuffling around there. And that's what I don't want to happen, because these numbers are like, this decryption thing is very big, so we're going to do a lot of shuffling around. So yeah, but we can probably also do a mod of this and be clever about how do we shuffle this. How the hell do we do this? Wait, I guess we could discard some things. If we know that we make one whole lap around the vector, we could discount, like we could not make that whole lap and just add 1 to the kind of shuffling that we are doing. I don't know if that makes sense. Well, I think I'm going to take a little break because I need to do a couple of things today. Maybe I can come back to this later at night or continue tomorrow, but I'm happy to have a part 1 solution, and I have to think about part 2, but maybe this is the kind of problem that it's better to think while going to the climate gym or something. So, well, that's been all for today. If you haven't, thanks for watching and see you later. Bye bye.